We are going to do is now we are just going to quickly run through the same things which were shown to you on the screen with an example, but I'm going to use a different data set which I have with myself, right? So I'll do one thing, I'll just try to convert something. So let me take some data. So let me take the Boston data itself, right? So let me first check the names of that. Right, so these are the data, and MEDV was a numerical variable which was my dependent variable in the linear regression. Let me check the summary for this data set first, and I'm saying Boston. So I'm going to convert this numerical variable into a categorical variable. So let me do that basis there is that anybody who is above the value, say the quartile 25, I'm going to treat them as a high value, right? So I'm saying median value in this case is high, right? So I'm using the same data, I'm just going to convert this and I'm creating a new variable. So class of MEDV, and I'm saying with an if else. I hope you all remember the if else command. Boston, if Boston $MEDV is greater than or equal to, so I can see the quartile as 25, so I'm just using that. Then I'm saying that this is high or else it's low, right? And just have a look at the data now. So view Boston, so this is how the data comes up. So this is MEDV, so I have done this transformation of classes of data. I can do something like a summary and check whether the data is really in the form which I expect. Okay, so it's not actually in the form in which I want it, right? So I have to convert this into a factor data so that it gets treated as, so I'm saying Boston dollar class score MEDV is allocation. I'm just going to copy this, that makes more sense. As dot factor, right? And then if I do a summary, so I'm just going to change this, right? So this makes sense. So I have 132 highs and 374 lows, so I'm going to do the modeling on the high basis that perspective. So how I'm going to use this, right? So I'm just going to say, let me first remove the MEDV from this data. So I'm just going to create an extract from this. So I'm saying Boston is nothing but Boston. I'm saying take all rows and remove, say, MEDV. Let me access this with the, so there are 15 variables, so let me remove 14, right? So I have removed the MEDV value and it's now having only class data. Just clean this. So I'm going to use this for my modeling with GLM function. So I'm saying model allocation sign GLM formula is MED is class underscore MEDV tilde a dot family is equal to binomial logit and data is equal to Boston, right? And then I do a summary of model. This is how my things are coming, right? So this says that the the residual deviance is 222, which is substantially lower compared to the null deviance, and which shows that it's a good model, right? And the iterations are 7, and that's how I see this now, right? So what I have to do is I have to just keep on doing the same thing, and I have to remove the variables which are not significant. So how I do that is I just go on reducing the variable list. So I keep on reducing this. This is not a good variable. This is not a good variable for my modeling, and I'll have to remove these things from my model and the final model which will be left will be a good model to use, right? So this is how you'll use relationship modeling in the data in which you're working. So let me just optimize this model with a step function, right? And then I do a summary of my model. So it has reduced my model to an optimized model, right? And then I can say that this is a very optimized model. 2 to 4 the residual deviance, the AIC has improved, right? All the variables are significant except this one which is on the border. Now it's my call whether I want to still retain this variable or not. I can further remove this variable by just going in over here and saying that okay, I don't want this, so I'm just going to copy this, and I'm saying model allocation GLM, and I can remove that variable which has 0.06. So I'm just going to remove NOx and do a summary of the model, right? So all my variables are significant and I can use this for the prediction. So when I want to do prediction, all I have to do is I have to say predict. So I'm just going to, if you actually see the predictions, right, what is going to come out as a prediction. So I'm going to write this in the Boston data itself. So I'm saying predict is nothing but predict dot glm, and over here I'm using the model, and the new data which I need to pass over here is, again I'm going to just wrap the same data because I'm just overwriting over here, and I'm saying yeah, this should be enough, right? And then if you do a view, this is Boston. So you can see this is the log odds, right? By default it's the log odds, right? And you can do the transformation of the same, right, if you want, or else you can directly do something like this, wherein you can say type is equal to response, and now if you see, this will be probability values instead of the log odd values. So that's all you have to do.